Okay, hello everyone. I'm sorry for this additional video because in class I'm not sure what is going in my applications for the good notes. I'm still looking for it. Actually, it's having the storage problem. I'm not sure what's happening, but I assure that all the storage is already clear and already enough memory. And I'm also using iCloud for 200 gigs and still it has some certain issues. So whenever they pop up the message, the recording is going to be disrupted. So let me just go brief and very fast because I tried this several times, and in the middle of the explanation is going to be some disruption. So okay, let me just go through the explanation on our class today. So we first start with parallel pipe. Okay, we can imagine the parallel pipe having an area of parallelogram in which it's a magnitude of the cross product of B cross C. Okay. If we have another vectors here, vector A, and we can relate this to a projection here, which is the height, we can calculate the volume of this geometric shape, and we can imagine the projections, and then we can imagine the cross product, and we can combine all together with the dot. Okay, and the implication, if this volume is 0, then all the vectors here, they are all in the same plane. And there are some property of the cross product. You may take some photo or screenshot if you want. Okay, now let me just go through the equation of line and plane. So first is line, okay, equation of line. So imagine we have these vectors, okay, the position vectors of P0 and P, which is R0 and R, and we have the vector A to connect this P0 and P, okay. And we have the relations with R0 and A. If A can be described as a parametric, okay, we can have another vector that is parallel with A, same, but it has the same directions, means then we can have our relations for A and B, and it is connected by the scalar T. Okay, the scalar T is our, we say this is our parameter, if you remember the parametric equations. And we can have the general equation for vector of L, or line L. Okay. And now if we see the and we can describe the line, okay, in terms of vector positions, and we can trace the T, we vary the T, and we can describe also the general form in terms of more expanded form, then we have the parametric equations. Okay, if we look here, which is x0 plus dA, all with the T, okay, and we can solve T and become the another form which we call the symmetric equation of L. And what's important here is all the forms here, they are based on the direction of this A and B and C. Okay, that the A, B, C is the key. And especially for this symmetric one, because A, B, C is on the denominator, then what's happened if we have A is equal 0? If A equals 0, then we go back to the definition here, which means that this A is 0, which means x is equal to x0. Implications are that the line will be on the vertical plane. Okay, so if we have the geometric space here, that this is x equal x0, which means that the line will be on the plane, okay, will be on this plane. So there will be no x directions for the vectors. Okay. And we have three conditions at least. Parallel, which is it's going to have the same direction. Intersection, this has one point that is having this in the they are equal on this point. Okay, and then the skew. Skew means not parallel and not intersected. Okay, now example is finding parametric and symmetric equations. Okay, the line is passing through AB, this point. Okay, so first we need to create our vectors. So the vectors we can create for AB or BA, it's up to you. Okay, so we can create the vectors and make that vectors as our directions. Okay, so it's also our A, B, and C. And then the follow-up questions is what point the line intersects XY plane. So okay, so first, okay, maybe before that we can describe this the ABC and then the initial point, and then write down the symmetric equations. Okay. Okay, now we are looking at the XY plane here. The XY plane will be crossing the z equals 0 here. So when z equals 0, we will intersect the XY plane. So the line will be intersect this XY plane when z equals 0. So z equals 0, and then we get the t, and using the t, we find x and y, and that's our point. We can do both for parametric or symmetric. We will have the same conclusions. Okay. And we can also write down the general formula for this case with this form here, but not really that important, but just to make sure you know of it. Okay, another thing on this line is we can make out line segment. So rather to look on the whole vectors here, we can take out just some element. Okay. Because in vectors, what do really means is just the directions. Okay. We don't really need to calculate the whole line. Okay. And we can calculate and make it into our line segment like this. Okay. And this is another example for proving whether the line 1 and line 2 are skew, or L1 and L2 is not parallel and also not intersecting. So first, parallel can be observed from the directions. Okay. You can see the directions. And the intersections can be proved from these equations. Okay. When you see any inconsistency, then your line is not intersected. And for this case, this line 1 and line 2 is skew. Okay. Implications. So we can have our distance, okay, our distance as the equal this formula. And then if we try to find distance between these two planes, in which these two planes are parallel, then we can take a point, okay, to make sure that this is the point on one plane, and then we can take the point and using to the formula of the distance, and we get the distance. Okay. I hope this can make up what lost in recording in the class. Okay.